What if the moment a bug was reported in your GitHub repo, the fix is already on its way? No developer ping, no Slack messages, and no context switching. Just an issue opened on GitHub, a label added, and 10 seconds later, there's a pull request. That's not a dream, that's what we are building today. So we are in 2026, and the conversation around software development has completely shifted. It is no longer about AI helping you to write code faster. It's more about AI writing you code even when you are not looking at it. Claude Code has changed how we build things. But what we are building today goes even a step further. A real-time GitHub Issue Resolver that watches your repository, reads your code base, understands the bug, generates a very surgical, precise fix, and opens a PR completely autonomously. This is not just a demo. This could be a production-grade architecture, an ASP.NET Core Webhook Listener, OptoKit for GitHub integration, and Claude Sonnet as the brain, and a CLAUDE.md file that acts as the AI's map of your code base. By the end of this video, your repo will fix itself. Let's just build it. Alright, so before I explain you anything, let me just show you what this system does. I have a simple to-do app running here, nothing special. You can add tasks, set priority, set the status, and cards are sorted by the priority. That's it. Now watch what happens when I go to GitHub and create an issue. Okay, issue created, bug label added. Now I switch to Visual Studio and I watch the output window. Webhook received, fetching files including called Claude.md, sending context to Claude, calling the API, Claude fix ready, confidence is high, creating the pull request, done. PR opened. A pull request generated automatically with the exact fix. 3 lines changed and nothing else. I merge it and there it is. That just happened in about 30 seconds. No developer touched the code. No one was pinged. The system read the issue, found the right file, and made the surgical fix and opened a PR for review. Now let me show you how it all works. So the system has 4 phases and let me walk you through each one. Now when someone opens an issue on your GitHub repo and labels it as a bug, then there is a webhook that has been attached to this repo. Now as soon as this webhook is fired, GitHub is going to make a post request to our webhook controller, and the first thing that our webhook controller does is to validate the HMAC SHA-256 signature. Now, GitHub signs every webhook payload with a shared secret, and if the signature doesn't match, the request is rejected immediately. Now, once validated, we fire 200 to GitHub immediately, even before any processing starts. And this is important because GitHub has a timeout. If we don't respond quickly, it will mark the delivery as failed and reject it immediately. So we fire the actual processing as a background task and let the GitHub go. Now, this is where the magic starts. Before we send anything to Claude, we need to give it the correct context, the right files from the code base. So this Claude.md contains the entire structure of the code base. It tells you what is the main files that we have got and what is the purpose of each file. Furthermore, it is also defining the logic that this app is holding. Also, there is a place where we have mentioned the common bug locations by the issue type. For example, if you have got a styling issue with a card, then probably or mostly this is the file that you have to look into. If there is some problem with the data that is being returned by the API, then you will have to look into this to-do controller or the to-do service file over here. Now, if we go back to our GitHub Issue Resolver repository, there is this method called fetch relevant files inside the GitHub service class. Over here, we are first fetching the Claude.md file so that my GitHub Issue Resolver, the Claude inside that, has got the entire context of what it is going to fix or what the repo is about. Once we have got that, we are going to fetch the keywords from the bug title or from the body, the description that has been mentioned. Once I've got the keyword, I've got the Claude.md file, my Claude will be able to figure out the content or the files responsible for this kind of issue. Most importantly, what is returned is a dictionary where the key is the file name and the value is the content of the file. So this is what get returns to the Claude. Alright, so now we call the Anthropic API with Claude Sonnet 4.5. You can of course choose another model if you want. And then there is a system prompt which tells Claude that it is a senior .NET engineer and an autonomous code fixer. We then pass the issue title and the issue body along with all the files that we just figured out might contain the root cause to the Claude. We then wrap all of it into an HTTP request along with the Claude or the Anthropic's API key. After that, Claude is just going to return a structured JSON and not just a text response. This will exactly tell which file to change, what text to find in that file, and what to replace it with. We call this a patch, a surgical find and replace operation. If everything worked so far, then we are going to use this octokit library, create a GitHub client from it, and then create a new branch, then apply the patch, commit the file, and then create a new pull request, automatically linked to the original issue. However, if anything fails, things like the API key was not configured for Anthropic or it did not find any matching string, we will post a failure comment directly on the GitHub issue. Now, three things in the system are worth calling out explicitly because they look simple, but it took real thought to get them straight. The first one is the Claude.md file. Without this file, the system is guessing. It extracts keywords from the issue and just hopes that they match a file. That works, but maybe just 40% of the time. But with Claude.md file, Claude always knows the full map of the codebase before it even starts to attempt anything. It knows the CSS variables in the app.css. It knows that the sorting logic lives in the to-do app service. It knows where to look before it even reads the issue. So every repo that you point this system to should have a Claude.md file. It is the single most impactful thing that you can add right now. Second, patch over the full file. Look at the instructions in the system prompt. When returning new content, the full file must be identical to the original except for the exact lines that require the fix. We spent a lot of iterations getting to this. Early versions asked Claude to return the full file with the changes applied. Claude would rewrite the entire CSS when you just asked it to change one color. But the patch model finds the exact string and replaces it, which actually makes Claude more surgical. It is not just better prompting, it is a different data contract. Third, failure comments. Every failure path in this system posts a comment back to the GitHub issue. Missing API key, patch didn't match, or Claude returned an invalid JSON. The developer finds out exactly what went wrong directly on the issue. This is what makes the system production ready versus just a demo, because silent failures break the trust. However, explicit failure comments build it. Okay, so now to set this up, you would need four things. First, you would need to clone these two repos. Now, the GitHub Issue Resolver is the agent and the to-do app or your own repo over here is the target. Now, clone the Resolver app in the Visual Studio and come to app settings.json file. And over here, you would need three things. First up is the GitHub token. Now, this is the GitHub personal access token with the repo scope. This lets the agent create PRs and read files. Then there is a webhook secret. This could be any random string which is used to validate the incoming payloads from the webhook. And then finally, your Anthropic API key. So the description contains the exact method to get all these things from GitHub and from the Claude. Now the next step is to set up the dev tunnel. So on the API project where you see this run button, there's a drop down, hit that and you will see this dev tunnels option coming up over here. Now you have to create a new tunnel, give it some name, then choose the tunnel type to be persistent so that every time you restart this tunnel or restart this project, you still have the same tunnel URL. Keep the access as public and hit OK. Now, once you have the tunnel created, hit this show dev tunnels and over here you would see that you have created a tunnel with the account and other things. Now, I'm not going to use this tunnel because I already have a tunnel. I'm going to delete this. Now, once you start this project, you would see the dev tunnel up and running. So now I've got this dev tunnel URL and now the next step is to use this to create the webhook on the GitHub. Now in order to set the webhook, you will go to your target repo, in our case which is the to-do app. Now inside this, go to settings, come to webhooks, now add a new webhook, verify your email. So I'm not going to do it, but I'm going to show you this existing webhook that I've got. So now how do you get this payload URL? Now recall when we started the dev tunnel on the GitHub Issue Resolver Web API project, we got this URL of the tunnel plus we got this webhook path. So we concatenate these two parts together and this is the URL that we get. After that, set the content type to be application JSON, and for the events, you just have to choose the issues one so that every time a new issue is created, this webhook is triggered. Once done that, just hit save. That's it. Now you can create an issue with a label as Pug and watch the output window of your Visual Studio. So in 2026, the question isn't whether AI can write code. We know it can. The question now is, where does AI sits in your workflow? Well, Claude Code sits next to you while you work. What we built today sits in the background while you don't have to. Your repo can now fix itself. What do you do with that? How far you take it? What repos you point it at? What trigger labels you define? That's all up to you. Both repos are linked in the description and a CLAUDE.md template file is also there. If this was helpful, you know what to do, and I'll see you in the next one.